In this video, I'll show how to prove a set equality similar to the one on the homework. In this case, we are going to prove the following. Given two sets, x and y, if the power set of x is equal to the power set of y, then x is equal to y. Okay. So again, here we have as our start that the power set of x is equal to the power set of y, and to end we want x equal to y. So in pretty much any set equality proof, we're going to want to prove that x is a subset of y and that y is a subset of x. So let's start with the x is a subset of y step. And generally these will always start with suppose that we have some element of x. So say little x is in big X. So now we have to relate this to the starting assumption that we have. How are we going to use this in conjunction with the fact that the power set of x is equal to the power set of y? Well, we know that the power set is the set of all subsets of x. So let's try to relate this element little x to some subset of x. Probably the easiest thing to do is to notice then the set containing x and nothing else is a subset of x. And that's by definition. The set only containing x is a subset of x because, look at everything that's in this set. It's only x. Is little x in big X? Yes, because we just supposed that it was. Okay. So since the set containing x, little x, is a subset of big X, that means that by definition, the set containing x is an element of the power set of x. Notice this sort of subtle distinction. The set containing x is a subset of x, therefore it is an element of the power set of x. It's not a subset of the power set of x, it's an element of the power set of x. Okay. Now, since the power set of x is equal to the power set of y, that means that the set containing x must be in the power set of y. Okay, but if the set containing x is in the power set of y, then by definition, the set containing x must be a subset of y. But then, by definition, we must have the element x in y. Thus, we have just shown that if little x is an element of big X, then little x is also an element of y. That, by definition, means that big X is a subset of y. Now, for the case where we prove that y is a subset of x, we notice that it's exactly the same argument, only flipped. So we can say symmetric.